modulation, demodulation of data, like modulation at the transmitter end and demodulation at the receiver end. तो ये जो है वो all this process is done at the physical layer, and this is depending upon what kind of transmission medium you are using. Okay, so basically function of physical layer is this. So we'll be seeing various type of transmission mediums. Okay. So this is a sender. This is a sender physical layer. This is a receiver. This is a receiver physical layer, and they are connected through a transmission medium. This transmission medium can be a cable. Different types of cables are there, or it can be a air interface. Okay. So it can be a wired or a wireless medium. So basically, what is a transmission medium? Sending of data from one device to another. It's called transmission of data. Medium used to transmit the data is called the transmission medium. Transmission of data through medium, it's called transmission media. So it is pathway that carries the information from sender to receiver. Now there are different kind of cables. If we are using wired media, or there can be waves which will be used for wireless transmission of data. So depending upon that, the waves, the data will be, that is digital data, zeros and ones, can be converted to electrical signals or electromagnetic signals. These electromagnetic waves. Okay, now it is below the physical layer. This transmission medium is below the physical layer, and so we will be seeing different types of transmission medium. Now, transmission mediums can be guided media or unguided media. Now, in guided media, you have twisted pair cable, coaxial cable, or fiber optic cable. In unguided media, you can have radio, microwave, you can have satellite communication. So it can be wired or wireless. Now, the characteristics and quality of that particular transmission medium will be determined by what kind of medium you are using. That is, transmit characteristics and quality of the data transmission will be determined by what kind of medium you are using and what is the type of signal. That is, whether you are using a electromagnetic signal, or you are using a light wave, or you are using a electromagnetic wave. So now, when you are using a guided media, okay, the medium is more important. That is, which kind of medium you are using. Whether if it is optical fiber, the data transmission will be through light. We know that optical fiber uses light as a transmission for the transmission. And if you are using coaxial cables or twisted pair, it is an electrical signal. So that time, when you are using a guided medium, the medium which you are using is more important. And when you are using unguided means basically it is a wireless medium. Okay, the bandwidth produced by the antenna is more important in case of wireless medium. Okay, and whenever you are using any type of this mediums, basically it is the data rate and distance which is to be concerned. Like what data rate you want, how you want the distance which you want to cover with the transmitter to receiver. What kind of this every medium is having its own characteristic, and they will be having their own parameters. That is what distance they can travel without attenuation. Okay, after that there will be some noise added or their performance degrades. So there is a distance to which they can perform well. So and the data rate which they can support, maximum data rate. So these are the concerned parameters, data rate and distance, when you are using any kind of medium. So depending on that application, the medium will be decided which kind of medium can be used. So guided transmission medium, when you are connecting one device to another device, and guided media means they will be like you know that you can see this twisted pair, coaxial cable, or optical fiber. These are the examples. So twisted pair cable, it uses a metallic conductor such as copper. You have two wires. These two wires are twisted. So two wires are the thickness is of about 1 millimeter, and it is in the twisted pair cabling. They are twisted, and they will be used in pairs. Okay? So this is the conductor wire, and we have an insulation along with that length of the wire. These are the insulators which will be covering. So each pair of wire will consist of one positive data signal and one negative data signal. So you have sometimes you have that red color wire, you have yellow or green color like that. So twisted pair cables are most effectively used in systems that use balanced line method of transmission. So they will be having one positive and one negative terminal. You can see over here. This is the conductor. This is the insulator. This is the cable jacket. They have twisted pair. There are 4 pairs in this particular thing. So one of the wires carry signal and the other is used for ground reference. So we have positive signal and negative. 2 wires are there. The receiver uses the different bandwidth uh, for like between the two levels. It uses the difference between the two levels. So whatever is the positive signal and negative signal, the difference between these two signals will be used by the receiver. If you increase the twisting, okay, the probability that both wires are affected by the noise in the same manner, the difference at the receiver remains same. So there are different category wires, like you have category 3, category 5, like that. So that if you increase the number of twisting, it's like, see, when you are using, there is an electrical signal which will be transmitted through the uh, wire. Okay, that is going to create a electromagnetic interference around it. So when you are using the twisting of the pairs, okay, there will be some electromagnetic uh, can say induction EMF, which will be mm, there, and which is going to cause the noise. Okay, so if you have more number of twist, the quality will be improved. Okay, because it is going to reduce that interference. So the number of twists per unit length determines the quality of the cable. Here you can see this is the twist, and like that there are number of pairs which you can have in a one cable, grouped in one cable. The application is like whatever your telephone line. The telephone network uses this twisted pair. Now this twisted pair between the homes and the local exchange. Within the building to private branch exchange for local area networks. LAN, which is like 10 Mbps or 100 Mbps speed. Now they are cheap, they're easy to work with, but they are having low data rate. They are short range, you cannot use the same wire for long distances. So that's why they are generally used between the house and the local exchange only. Bandwidth depends on the thickness of the wire and the distance traveled. Transmission characteristics. It uses electrical signals, which is analog. Okay, so it amplifies when you are using this analog amplifiers, every 5 kilometers to 6 kilometers are required. So the signal has to be regenerated, amplified after every 5 kilometers or 6 kilometers run. Digital, it uses either analog or digital signals, and you require repeater. In this case, you require repeater of 2 kilometers or 3 kilometers. So when you use a digital line, then you have to the distance is reduced. So this is used for limited distance, limited bandwidth, limited data rate. It is susceptible to interference and noise, as we have already seen. To this, around this particular wire, since it is carrying an electrical signal around this wire, there is a electromagnetic interference which is generated, and which is going to, like in landlines, you must have heard about the crosstalk, because signal from one line gets transferred, that electromagnetic interference, due to this the signal gets transmitted from one line to another line. So there is a crosstalk, so they are susceptible to interference and noise more. Security is also low. Now in this you have two types. You have UTP and STP. UTP is unshielded twisted pair and STP is shielded twisted pair. So the difference is like these are the two cables which are twisted, and to this you have a metal shielding. So when you have a shielded twisted pair, you have a one metal shield which is covering these two lines. Okay. Now this unshielded, that is UTP, is used on Ethernet 10 by T. There are different connectors. This when you are using this, there will be different kind of connectors, RJ45, RJ11. And in STP, it is used with the traditional token ring cabling. It requires custom connector. So characteristic impedance of 150 ohms. This is a UTP connector, like this is the RJ45. These are connectors. UTP is like your ordinary telephone wire. It is cheapest because it doesn't have the cost for that metal shield covering. It is easiest to install, but it suffers from external EM interference, that is electromagnetic interference, which is generated because of the transmission of electrical signal. In shielded twisted pair, it is more expensive because of that